Hello students, today we study the part of a ray optics refraction. In the last class, we study about what is meant by reflection. When the ray of light is incident on a surface or incident on the mirror, it comes back into the same medium. That process is known as a reflection. So the next part, when the ray of light is incident on the medium, it passes from one medium to the other medium. That time, the ray of light is a bends. That bending of ray of light is known as a refraction. Bending of a ray of light. When the ray of light is a passes from one medium to other medium, that process is known as a refraction. So we know that in a homogeneous medium, the speed of light is the same. In the homogeneous medium, the speed of light is the same. But when the ray of light is a passes from one medium to the other medium, the velocity of the light is a changes. And due to the change in velocity, the direction of the ray of light is also changes. So that the change in direction is known as the refraction. So here the refraction in the light, when the ray of light, when the ray of light, the ray of light passes from one medium, one medium, one medium to other medium, to other medium, one medium to other medium, the direction is a changes. And that change in direction is known as a bending of a light to the other medium. Change in direction of ray of light. That process or bending of light, bending of light, bending of light. When it passes from one medium to other medium, is known as a refraction. Is known as a refraction. Known as a refraction. So when the ray of light is an incident on the surface, some part of the light is a reflected, some part is a refracted. Then the intensity of a refracted light is a less as compared to the reflected light. So that the intensity of a refracted light is a less as compared to the incident light, because some of the intensity of the light is decreases due to the reflection of a light. So in this type we study about the refraction. So what happened when the ray of light is passes from the one medium to other medium? So first we study about refraction through the plane surface. First we study about refraction through the plane surface. Refraction through the surface. Refraction through plane surface. Refraction through the plane surface. Through plane surface. Plane surface. In the last class, we study about the polished surface. Due to the polished surface, the ray of light is come back in the same medium. But if we take the plane surface, so here this is a plane surface. When we consider this type of surface, on this surface when the ray of light is an incident, plane surface which is a homogeneous. So there are two parts are there, in which the density is a less. In which the density is a less, that medium is known as a radar medium. In which a denser medium is that, in which the density of that medium is a more. Or in which medium the velocity of light is a more, that medium is known as a radar medium. and in which the velocity of light is less, that medium is known as a denser medium. So if we compare the medium, both these mediums are optical medium. Optical mediums are those which allows to propagate the ray of light through it. So in this type we consider the two medium. So this is a air medium. Means here the air is there. So this medium is known as an air medium. Otherwise, if we compare here water and glass, that time water is known as a rarer medium because the density of a water is less than the density of a glass. So in this type we consider the two medium. Suppose this medium 1, suppose this is a medium 1, and this is a medium 2. Medium 2. Medium 2. Suppose this medium is a radar medium. Radar medium is a that. Radar, radar medium is a that. Radar medium is that where density is a less. Where density is a less. Density is a less. Denser medium is that. Denser medium is that where density is more. Where density is more. Density is more. Means there are two mediums are required to compare the two medium. If we compare air and water, when we compare air and water, the density of air is less than the density of a water. So air is known as a rarer medium and water is known as a denser. If we compare in between water and glass, the density of water is less than the density of gas. So that time we consider water is a rarer and a denser, that gas is a denser. So in this type when we compare the two medium, that time we consider rarer in which the velocity of light is a more and in which the velocity of light is a less, that is known as a denser medium. So in this type we compare the less density is a rarer and more density is a denser. So what happened when the ray of light is a propagate from one medium to other medium? When the ray of light is a passes from one medium to the other medium, it changes its direction, and that change in direction is known as a refraction of a light. So here, if we compare the two medium, suppose this is the first medium, which medium is a radar, or if we consider this is a air medium, and suppose this is another medium, if we consider this medium is a glass. Means this is a radar medium and this is a denser medium. Means the ray of light is a passes from air to glass. Then we know that in the homogeneous medium is a that where the density is the same. So in this type, this is also homogeneous, this is also homogeneous. So when the ray of light is a propagate, the speed of light is the same in the homogeneous medium. Then here, when the ray of light is a propagate from the medium 1 to medium 2. But so suppose the ray of light is a incident obliquely. This ray of light, suppose this is a PQ. This PQ is known as an incident ray. PQ is known as an incident ray. Then draw a straight line at the point of incidence. PQ is an incident ray. Draw a straight line at the point of incidence. Draw a straight line at the point of incidence. That ray is known as a normal ray. Suppose this is a M. MN is known as a normal ray. This PQ is known as an incident ray. So PQ is incident, MN is normal. Means when the ray of light is a passes. So ray of light is a passes obliquely, which is an incident on the glass. Means the ray of light is a passes from this radar medium to the denser medium. Then here, when the ray of light is an incident at this point, and this is an interface in between the both the medium. This layer or this surface is known as the interface in between the two medium. So when the ray of light is incident on the interface in between the two medium, it changes its direction. Because of this glass, the ray of light is passes through this medium. So glass is allowed to propagate the light through it. So glass is medium, it changes its direction. Then here what happened here? It changes its direction. So this bending of light ray is known as a refraction. If the plane surface is not there, if the medium is the same, at the this medium 1 and medium 2 is the same, that time the ray of light is a propagate in the straight line direction. Means this is the ray of light is a propagate in the straight line direction. If the medium is not changes, means this ray is known as a normal ray. This ray is known as a normal ray. This ray is known as an incident ray. So this ray is known as an incident ray. This ray is known as a refracted ray. This ray is known as a refracted ray. Refracted ray. This ray is known as a normal ray. Normal ray. So see the figure. PQ is known as an incident ray. MN is the normal ray which is drawn at the point of incidence, and when the ray of light is passes from one medium to the second medium, that time the ray of light is changes its direction. This ray of light is changes its direction, and this change in direction is known as a refraction. And this refraction is takes place due to the change in velocity. There is here the angle which is find out. The angle which is find out in between the incident ray and normal ray, that angle is known as the incident angle R. The angle which is find out in between the incident ray and the normal ray, that angle is known as the incident angle. The angle which is find out in between the incident ray or the angle which is find out in between the normal ray and refracted ray, that angle is known as the angle of refraction. So in this type, when the ray of light is propagate from one medium to another medium, it bends. It bends or it changes its direction. That process is known as a refraction. So here, explain the figure. When PQ is the incident ray, PQ is the incident ray, MN is known as a normal ray, MN is known as a normal ray. The angle which is find out in between the incident ray and normal ray, that angle PQM. The angle PQM, that angle is known as the angle of incidence. Angle of incidence. Angle of incidence. Let us see the second part. QR is known as a refracted ray. And the angle which is find out in between the refracted ray and normal ray, that angle is known as a refracted angle. So this is a NQR. Angle NQR. This angle is known as the angle of refraction. Angle of refraction. Angle of refraction. Angle of refraction. So this angle is known as the angle of incidence. This angle is known as the angle of refraction. Angle of refraction. Actually, this angle of incidence and angle of refraction both are same, but due to the change in medium, the angle changes, and that change in angle is known as a deviation. That change in angle due to the change in medium is known as a deviation. Therefore, deviation in this figure D is equal to where angle of incidence is more as compared to the angle of refraction. Therefore, D is equal to I minus R. D is equal to I minus R. So this figure is related when the ray of light is passes from the rarer medium to the denser medium. So according to this, when the ray of light is propagate from rarer to denser, it bends towards the normal. So here, when the ray of light is propagate, when the ray of light propagate from denser, it bends towards the normal, towards the normal, towards the normal. So in this type, when the ray of light is a propagate from this medium is a rarer, this medium is a denser. Means when the ray of light is propagate from rarer to denser medium, it bends towards the normal, and here the angle of incidence is more than the angle of refraction, and change in path of the ray of light is known as a deviation. So change in direction of the ray of light is known as a refraction. So that refraction, or what is the angle with which the ray of light is refracted, find out by using the formula D is equal to I minus half. So in this time, we can draw the figure when the ray of light is propagate from rarer medium to the denser medium. Second, when the ray of light is propagate from denser to rarer. When the ray of light is propagate when the ray of light is propagate from denser to the rarer medium. When the ray of light propagate from denser to when the ray of light is propagate from denser to rarer medium. Denser to rarer medium. So first, if we consider the denser, means from air to glass, again glass to air, means when the ray of light is incident of the window and again enter in the room, means that time the ray of light is propagate from the air to the denser and again coming out in a rarer medium. So here what happened when the ray of light is propagate from denser to rarer? Draw a plane surface. Suppose this is a plane surface which is an interface in between the denser and the rarer medium. The second medium is a rarer. Here the density is a more and here the density is a less. If we consider this is a glass medium and this is an air medium. Otherwise, if it is considered as a glass and if it is a water, so that time what happened? So take the incident ray, which is the incident. Incident ray is that a ray of light which is a incident on the plane surface. That ray is known as the incident ray. Suppose PQ with the incident ray, which is the incident of the surface obliquely. Then at the point of incidence, this point is known as a point of incidence. Draw a straight line at the point of incidence. This ray is known as a normal ray. So this is a MN. This ray is a normal ray. And this angle is known as a angle of incidence I. The angle which is found out in between incident ray and normal ray is known as the angle of incidence. So this ray of light is a passes from this denser medium to rarer medium. So here, if the medium is not changes, the ray of light is a propagate in the straight line direction. The ray of light is a propagate in the straight line. If the medium is not changes, means this is a imaginary light. This ray is known as a incident ray. Imaginary means if the medium is not changes, the ray of light is a propagate in the straight line. But due to the change in medium, that ray of light is a passes from denser to rarer. So in the denser, velocity of a light is a less, and in the rarer, the velocity of light is a more. So when the speed of light is a changes, that time the ray of light is a bend away from the normal. So here, because the ray of light is enter from the denser to rarer, that time the ray of light is bends away from the normal because its velocity is increases. So this is a bending away from the normal. So this ray is known as a refracted ray. Refracted ray. This ray is known as a normal ray. Normal ray. This is a imaginary line. So see the figure. PQ with the incident ray, and this incident ray is a passes from the denser medium to the rarer medium. Rarer medium means where the density is less. So when the ray of light is a passes from denser to the rarer medium, at the point of incidence, there is a bend of light, and this bending of light is known as a refraction. So this is a ray of light is a bends, and in this the ray of light is a bends away from the normal. When the ray of light is a passes from rarer to denser, it bends towards the normal because its velocity is a decreases. But when the ray of light is a passes from denser to the rarer, that time its velocity is a increases, so it bend away from the normal. So here this angle is known as the angle of incidence. So here PQ is known as a incident ray. Incident ray. PQ is known as the incident ray. QR. QR. QR is known as a refracted ray. Refracted ray. And FM is known as a normal ray. Normal ray. PQ incident ray, MN normal ray, QR with the refracted ray which bends away from the normal when the ray of light is propagated from the denser to the rarer. So here the angle PQM is known as the angle of incidence. The angle which is found out in between the normal and the incident ray, that angle is known as the angle of incidence. Therefore angle PQM is equal to angle of incidence I. And the angle which is found out in between the normal ray and refracted ray, that angle is known as the angle of refraction R. Therefore, angle NQR, 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 that angle is known as angle of refraction R. So here, the angle of refraction is more than the angle of incidence. Therefore, the deviation of a ray of light is deviation is equal to R minus R. So this is a related formula to find out the deviation when the ray of light is propagated from the denser medium to the rarer medium. So in this type we use the ray diagram when the ray of light is passes from the rarer to denser, and this is the ray diagram which is related from the denser to the rarer medium. So give the RMS, this is the incident ray, this is a refracted ray. This ray is known as a normal ray. This is the angle of a refraction. This change in angle is known as the angle of a deviation. So this process is known as a refraction. So this is a related figure when the ray of light is propagated from rarer to denser. When the ray of light is propagated from rarer to denser, it bends towards the normal. And when the ray of light is propagated from denser to rarer, that time it bends away from the normal. Means when the ray of light is propagated from rarer to denser, its velocity decreases. But when the ray of light is propagated from denser to rarer, its velocity increases, so it bends away from the normal. And this process of a bending of a ray of light is known as a refraction. When the ray of light passes from one medium to other medium, there are some laws are there, and those laws are known as the laws of a refraction. Laws of a refraction. In the refraction, we study about the laws of reflection, and in this we study about the laws of refraction. So when we study about the laws of refraction, the first law is all the incident ray normal to the point of incidence to the point of incidence to the point of incidence and refracted ray all are like at the same point or same plane. All the incident ray normal to the point of incidence and refracted ray all are like at the same plane. So this is a plane surface. This is an incident ray. Draw a normal ray at the point of incidence. So this is a MN PQ. So here PQ is this point. MN is also at the same point. QR is also at the same point. So this is a refracted. Suppose this is a radar medium. This is a denser. So PQ incident ray, MN normal ray, QR refracted ray, all are like at the same point. So this is known as the first law of refraction. The second law is according to this law, angle of incidence or sine of an angle of incidence is directly proportional to the sine of angle of refraction. Means refracted angle depends upon the incident angle. Refracted angle depends upon the refracted angle. So here, this is known as the angle of incidence. This depends upon the angle of refraction. Means if the incident angle increases, the angle of refraction is decreases. Means I is directly proportional to R. So angle of incidence is directly proportional to the angle of refraction. So this is known as the Snell's law. The second law is a very important, that this law is known as the Snell's law, and according to the Snell's law, the sine of the angle of incidence is equal to sine of the angle of refraction. So here the second law, this law is also known as the Snell's law. Snell's law. According to the Snell's law, the sine of an incidence angle, sine of an incident angle is directly proportional to sine of a refracted angle. According to this second law, this law is known as the Snell's law, and according to this law, the angle of refraction depends upon the angle of incidence. Means angle of incidence it changes, the angle of refraction is also changes, and both are directly proportional to each other. So this law is known as the sine I is directly proportional to the sine R, and therefore this law is equal to sine I is equal to constant of a constant. If we remove the proportionality sign, we take here constant. Sine I is equal to constant into sine R. Therefore, sine I divided by sine R is equal to constant. Sine I divided by sine R is equal to constant, and this constant in this chapter is denoted as a n or mu. This part is denoted by the n or mu. So according to the Snell's law, n is equal to sine I divided by sine R. That is, the sine R is directly proportional to the sine R. Therefore, we remove the proportionality sign. Sine I is equal to constant into sine R. If we consider here constant in this chapter is denoted by the letter n, or this letter is also denoted by the letter mu or n. Therefore, n is equal to sine I by sine R, and this n is known as the refractive index of the medium. So this n is known as the refractive index. This n is denoted as a refractive index of the medium, and the value of n is depends upon the medium, from which medium to the which medium the ray of light is propagated. Therefore, n is equal to sin I by sin r. So this is the law. This law is known as a Snell's law. Let's see here what about the n, or how the n is denotes, or how the n is defined. So in this slide, there are two laws of diffraction. The first law is all the incident normal to the point of incidence and the refracted ray. All the three rays are lies at the same plane. And the second law is known as a Snell's law. And the Snell's law is a sign of incidence is directly proportional to the sign of a diffraction. Therefore, sin I by sin r is equal to constant, and this constant is denoted by the letter n or mu. So this mu or n is known as the refractive index of that medium. Let's see how we write this refractive index. For the first, when the ray of light, when the ray of light, the ray of light propagated, light propagated from first medium to second medium, first to second medium, or rarer medium to denser medium, rarer medium to denser medium. Rarer medium is that where the velocity of light is a more or the density is a less. Denser medium is that where the density is a more and the velocity is a less. This here, when the ray of light is propagated, draw a plane surface. Draw a plane surface which is the interface in between the two medium. Suppose this is a plane surface, not a polished surface. This is a plane surface. So when the ray of light is passes obliquely, that medium is a one rarer medium. This is a rarer medium, and this is a denser medium. Denser medium. So this is a medium one, and this is a medium two. So when the ray of light is passes from which medium? Rarer to the denser. So this is a ray of light is passes from the rarer medium. Give the arrow mark. This is the incident ray. Draw a normal to the point of incidence. This is a normal ray. This is an imaginary line which is a drawn. So this is a normal ray. If we give the name M here, the angle which is find out, that angle is known as R. If the medium is not changes, the ray of light is propagated in the straight line direction. If the medium is not changes, if the same medium is there, in the homogeneous medium, the ray of light is propagated in the same direction. So this is a incident ray. Due to the changing medium, the ray of light is passes from rarer to denser. When the ray of light is passes from rarer to denser, it bends towards the normal. So here this is a refracted ray. When it bends, it will move in the straight line direction. So here this is a refracted ray QR. This angle is known as the angle of refraction R, and this is known as the angle of deviation D. And D is equal to I minus R. So according to the Snell's first law, the angle of incidence is directly proportional to the angle of refraction. So here the Snell's law is valid, but sometimes the Snell's laws are not valid. Means there are some limitation for the Snell's law. The Snell's law is not applicable for the normal ray. So the limitation for the Snell's law is that the angle of incidence is equal to 0, means angle of refraction is also 0. Because of that, the limitation for the Snell's law is the Snell's law is not applicable for the normal ray. Means when the ray of light is incident obliquely, that time this Snell's law is applicable. So here, when the ray of light is propagated from the rarer to denser, means according to the Snell's law, this is sin I divided by sin I is directly proportional to sin R according to the law. So here sin I divided by sin R. Sin R is equal to, we take the proportionality constant here. But here, from where to where the ray of light passes is important. The ray of light is passes from rarer to denser. The ray of light passes from the one medium to the second medium. Then see how to write this. The ray of light is passes from first medium to second medium. Writing this slide, the ray of light is passes from the one medium to second medium, means one here and two here. The ray of light is passes from first medium to second medium. Otherwise, we also write here sin I divided by sin R is equal to, we write here n2 divided by n1. So this formula is known as a Snell's formula, or this is a very important formula, that is the sin I by sin R is equal to n2 by n1. There is a sin I by sin R is equal to n2 by n1. When the ray of light is a passes from first medium to second medium, the ray of light is a propagated from one medium to second medium. When the ray of light is propagated from rarer to denser, it bends towards the normal. Therefore, in this, the deviation is equal to I minus R. So otherwise, when we apply the Snell's law, that time the Snell's law is, according to the Snell's law, when we apply the Snell's law for this figure, Snell's law is equal to sin I is directly proportional to sin R. Therefore, sin I by sin R is equal to constant here. But we denote here the ray of light is propagated from first medium to the second medium. Therefore, 1, n, 2, where n is known as a refractive index for that medium. Therefore, sin I by sin R is equal to n2 by n1. So here, the refraction of a light, the bending of a light depends upon the medium. Bending of a light depends upon the medium where the refraction takes place. So the value of n is not constant for each medium. It is a constant for that particular medium only. So refractive index for the air, refractive index for the glass, refractive index for the water, all the values are different. But those refractive index are related for that medium. Means that value is a constant for that medium. So the refractive index does not depend upon the incident ray. The refraction takes place depends upon the medium, depends upon the second medium, on which medium the ray of light is incident. If the ray of light is incident from the air medium to the water medium, means air is also rarer medium and water is a denser medium. That time again the refraction takes place, but that deviation as compared to other medium, means if we take the another one medium, that is a refraction which takes place from the air medium to the glass medium. That time in the glass, the bending of a light is more as compared to the bending of light in the water medium. So this refraction depends upon the medium where the ray of light is incident. Means the angle of refraction depends upon the medium, and that is known as the refractive index for that medium. So this n value of a n depends upon that particular medium, and that is not depend upon the incident ray, that is depend upon the medium. So the angle of refraction depends upon the medium where the ray of light is refracted. So this is known as the refractive index. So in this type, when the ray of light is propagated from one medium to other medium, that time we write the formula n2 by n1. Otherwise, if the medium is n21, means second medium to the first medium, that time we write here n1 divided by n2. So this is related, or we apply the Snell's law for this. That is a sin I by sin R is equal to n2 by n1. Or when the ray of light is propagated from denser to rarer, that time we use the formula 2 to 1, means n1 by n2. So here, when the ray of light is propagated from rarer to denser, in this, due to the change in velocity, the direction it changes. And we know that when the ray of light is propagated, if the ray of light is a composite, means there are different colors are there. So that bending of light means there are three parameters are there. The one is a velocity, second one is a frequency, and third one is a wavelength. So when the ray of light is passes from one medium to other medium, in the refraction, frequency of the ray of light is does not changes, but the wavelength is a changes. So on which factor the velocity is a depend. So here, the next part, refractive index or the absolute refractive index. Absolute refractive index of the medium. Refractive index is that in which due to that the ray of light is a base. So the absolute refractive index is defined as absolute refractive index, or we know that the refractive index is denoted by the letter F. So absolute refractive index is that in which we compare the velocity of a light in the air to the velocity of a light in other medium, where c is the velocity of a light in air and velocity of light in air is a constant, that is a 3 into 10 to the power of 8 meter per second. But when it is enter into the other medium, its velocity is changes due to that change medium. So we use here n is equal to c divided by v. So this ratio is known as the absolute refractive index for the medium. That is n is equal to c by v. Then the second, relative refractive index. Relative refractive index of the medium. So relative refractive index of the medium is defined as refractive index of the medium 1, refractive index of the medium 1 to the refractive index of medium 2. Refractive index of the medium 1 to the refractive index of the medium 2 is known as the relative refractive index of the medium. Then say refractive index of the medium is a c divided by, when the medium are changes for the first medium, if the velocity is a v1, for the second medium, when the velocity is a v2, then c divided by v1 divided by c divided by v2, means we got here v2 divided by v1 c. C get cancelled. Therefore, we got the formula V2 divided by V1. So here, relative refractive index of the medium. That is the relative refractive index for the refractive index for the medium 1 to medium 2. Medium 1 to medium 2 is equal to. Otherwise, the ray of light is propagated from first medium to second medium. The ray of light is propagated from first medium to second medium. Then we write here n2 divided by n1. Otherwise, when the ray of light is propagated from the second medium to first medium, we write here v1 divided by v2. Means n1 by n2 is equal to v2 by v1. So we got the formula n1 by n2 is equal to v2 by v1. So this is known as a relative refractive index. That relative refractive index is equal to n1 divided by n2. So when the ray of light is propagated from first medium to the second medium, 1 to 2, or the ray of light is propagated from the second medium to the first medium. So that time, the relative refractive index for the first, n is equal to c by v1, n1 is equal to c by v1, and n2 is equal to c by v2. Therefore, n1 by n2 is equal to, we take the reciprocal of this, and we got here v2 divided by v1. Means the velocity is a changes depends upon the refractive index of that medium. If the refractive index is a more, velocity of a light is a less. Therefore, n1 by n2 is equal to v2 by v1. This is a shortcut formula to find out the velocity of any medium. Otherwise, if we want to find out the wavelength of each color, velocity is equal to frequency into wavelength. In the last year, we studied about that V is equal to F into lambda. Therefore, F into lambda. The velocity of the F in second medium, F into lambda 2. For the first medium, F into lambda 1. F get cancel. Is here, N1 by N2 is equal to V2 by V1 is equal to lambda 2 by lambda 1. So this formula is related to find out the velocity as well as the wavelength for any medium. Next part of this chapter is principle of reversibility. Principle of a reversibility. A principle of a reversibility is that when the ray of light is propagated from one medium to the other medium, when the ray of light is propagated from one medium to the other medium and again come back due to the same some reason in the same medium, when the ray of light is propagated from one medium to the other medium and due to the some reason it again come back in the same medium on the same path is known as the principle of a reversibility. So here, principle of a reversibility. When the ray of light, when the ray of light, ray of light, when the ray of light propagate from one medium to other medium, one medium to other medium, due to some reasons, it again come back in same medium, it again come back in the same medium is known as principle of a reversibility. Means when the ray of light propagates from one medium to the other medium and it again come back in the same region on the same path, it again come back in same medium on the same path, same path is known as the principle of reversibility. Means the direction of a refraction and direction of a reflection both are same. The way of passing and the way on which the ray of light coming back, both the rays are same. That process is known as the principle of a reversibility. Means when the ray of light propagate from one medium to other medium due to some reason, it come back in same medium on the same path. That process is known as the principle of a reversibility. Means in this, we draw a ray diagram as well as we can find out one related shortcut formula. So here how we draw the figure. If we consider the rarer medium, and again we consider the rarer medium, first consider a plane surface. A plane surface is that which is the interface in between the two medium. That surface is a plane. So when the ray of light this is a refracting surface. Means this is an optical medium which allow to propagate the ray of light to one medium to the other medium. So suppose this is a radar, means suppose this is a air medium, and suppose if we consider there is a water medium. Suppose this is a medium 1 and this is a medium 2. This is a rarer medium and this is a denser medium. Rarer medium is that where the density is less. Denser medium is that where the density is more. So this is a rarer medium. Take a ray of light which is an incident obliquely. For the normal ray, the Snell's law is not applicable. For the normal ray, diffraction is not possible because the angle of incidence is 0, angle of refraction is also 0. So take the incident ray obliquely. Suppose this is a incident ray. Draw a normal to the point of incidence. This ray is known as a normal ray. So this angle is known as angle of incidence. If the medium is not changes, this is water medium. If the medium is not changes, this medium both are same. Is the ray of light is propagating the straight line. This is the imaginary line. So this ray is known as a incident ray. This ray is known as a normal ray. This angle is known as a incident angle. So when the ray of light is an incident, PQ with the ray of light is an incident, which is an incident with the angle of incidence I. This ray is a draw a normal line at a point of incidence. Here, the ray of light is a refractive, and the ray of light is a passes from rarer to denser. When the ray of light is passes from rarer to denser, it bends towards the normal. So draw here, it bends towards the normal. So this is a refractive ray. This ray is known as a refractive ray, and this angle is known as the angle of refraction R. But here, in the water, suppose there is a mirror is there. In the water, if the mirror is there, in the water, there is a one mirror is there. So what happened due to the mirror? Mirror obeys laws of reflection. Mirror obeys laws of reflection. Means when the ray of light is passes from rarer to the denser, it bends from the normal. And this process of a bending of a light ray is known as a refraction. And the ray of light is passes from rarer to the denser, so it bends towards the normal. But in the water, if there is a mirror is there, and due to the mirror, there is a reflection is takes place. So here PQ with the incident ray, QR with the refractive ray, but due to this mirror, the ray of light when incident on the mirror, it reflects back. First PQ incident ray, QR refracted ray, but due to this mirror, the ray of light is a reflected back. So when this is reflect, so here QR with the refracted ray, when it is an incident on the mirror, it get back. It is a reflected on the same path. It is a reflected because when it is a normal instance, I is equal to 0, means the angle of reflection is also 0, which obeys the laws of reflection. The ray of light is, suppose we imagine here, suppose the ray of light is an incident normally on the plane mirror. That time the angle of incidence is 0. Therefore, angle of reflection is also 0. Therefore, the ray of light is reflected back in the same way. So here, so the ray of light is reflected back. Again, when the ray of light is an incident here, first PQ incident ray, QR is a refracted ray. But second time, when the ray is incident on the mirror, RQ is the incident ray. RQ is the incident ray, and this ray of light is a passes from which medium? Water medium to the air medium. Means the ray of light is a passes from a denser medium to the rarer medium. And according to the law, the ray of light is a passes from denser to the rarer, it bends away from the normal. So on the same way, same path, the ray of light is a come back. On the same path, the ray of light is a come back. So this process is known as a principle of irreversibility. This process is known as a principle of irreversibility. Means on which path the ray of light is a propagate, on the same path the ray of light is a come back in the same medium. That process is known as a principle of irreversibility. So what happens here? For the first, PQ is the incident ray, QR is the refracted ray for the first part. Due to the mirror, the reflection takes place. Means second part, RQ is the incident ray. When RQ passes in the same way, which is the incident on the plane surface, and this ray of light is passes again from the denser to the rarer, means it move away from this normal. So that time, this is a again refraction is a takes place, and on the same path, the ray of light is a come back. So here, which are the we apply the refraction law or Snell's law of refraction. According to the Snell's law of refraction, sin I divided by sin R for the first part. First part, when the ray of light is refracted from one medium to second medium, angle of incidence is I, angle of refraction is R. So sin I by sin R is equal to the medium is N1 to N2, or the medium is the ray of light is propagated from air to water medium. 1 to 2, one is air, second one is water. So this is the equation number 1. But when the ray of light is come back in the same medium, that time again we apply the same law. Here, the incident angle, the ray of light is come back in the same medium. The incident angle is R. So therefore, sin R divided by the refracted angle is I. Sin R by sin R is equal to the ray of light is passes from water medium to air medium. Equation number 2. So divide both the medium, divide both the equation. Sin I by sin R into sin R divided by sin I by sin R into sin R by sin I is equal to ANW into air to water medium into water to air medium. Multiply both the equation. Sin R get cancelled, sin I get cancelled, and we got here 1. 1 is equal to ANW into WNT. So we got here a shortcut formula, that is ANW is equal to 1 divided by water refractive index to the air medium. Means when the ray of light is propagated from first medium to the second medium, and the ray of light is come back on the same path on the same medium, that time the refractive index is a reciprocal of the first medium, that is ANW. For example, the refractive index for the second medium is 4/3. Then we can find out the refractive index for the first medium is 3/4 by easy method. So this is the known as a principle of irreversibility.